Hello my dear children, welcome to Chem Chemistry. I hope that you are preparing well for the upcoming JEE exam. In today's video, I am going to take up the questions related to colligative properties from the chapter solutions. So without wasting much of your time, let's begin. The first question says K2HgI4 is 40% ionized. So 40% ionized means alpha is equal to 40%. So that gives you 0.4. The value of Vent-Off factor is, so I is equal to, this you have to find out. So you know the formula for I, or you can say alpha. Alpha is equal to I minus 1 upon n minus 1. So this formula is applicable when the dissociation happens. Okay. Now how the K2HgI4 dissociates? See, this is the complex compound and it will dissociate to give 2 of potassium ions and 1 of this mercuric iodide ion. Okay, so total number of ions here would be 3. So when you substitute the value 0.4 is equal to I minus 1 upon 2 minus 1. So when you solve, you will be getting I is equal to 1.8. Okay, so the final answer of this question is 1.8. That means option B is correct. Now the next question is, for 1 molar aqueous solution of the following compounds, which one will show the highest freezing point? So you know this thing that the depression in freezing point, that is a colligative property. Okay, and colligative property depends on the number of particles. Okay, now when there are more number of particles, that means there would be more depression. There would be more depression in the freezing point. That means freezing point will reduce to the maximum extent. So here we have to find out the highest freezing point. So highest freezing point will be for the one which is having the least number of particles. I repeat, when you have more number of particles means more depression. So when you have to find out the more freezing point, that means you have to find out the less number of particles. Okay, because number of particles are directly proportional to depression of freezing point. So if you want the more freezing point, the highest freezing point, you want the less number of particles. So out of the 4 options given, you can see that all of these are the coordination compound, or we can say complexes. In case of complex, what happens? The entity, the coordination entity will not dissociate. Only the particles, the ions which are written outside the bracket or outside the coordination entity, only they will dissociate. Okay, so out of the 4 options given, I can see that in the D option, there would be least number of particles produced. Why? Because in this case, there are no ions present outside the coordination entity. Okay, so there are no ions. So how many particles are produced? When it will dissociate, only one particle is there. Okay, only one particle is there in case of D. If I ask about C, in case of C, you can see that coordination entity. So one ion will be produced from the coordination entity and one ion will be produced from the chloride ion which is present outside the bracket. Okay, so total number of particles would be 2. In case of B, one ion is produced from the coordination entity and the 2 ions are produced from the 2 chloride ions outside the bracket. That means total number of particles are 3. In case of A, there is 1 ion produced from the coordination entity and 3 ions are produced from chloride. So total number of particles are 4. So I can see that in case of D option, the least number of particles are there. When the particles are least, that means freezing point would be highest. So the correct option of this question is D option. Now this is another very interesting question. It says that pure water freezes at 273 Kelvin and 1 bar pressure. The addition of 34.5 gram of ethanol to 500 gram of water will change the freezing point of the solution. The freezing point depression constant is also given. Okay, and you have to choose the correct graph out of the 4 graphs given. So you know this thing that here WB, which is ethanol. So the mass of ethanol given, that is 34.5. It is a solute. okay, and it is dissolved in the solvent water whose mass is 500 grams, okay. Now you know the formula that delta TF is equal to KF into WB upon WA MB into 1000. So this is a formula you know. Now delta TF, that is the depression in freezing point. So depression in freezing point is not given. So this you can calculate. KF value is given. KF is 2 and WB is 34.5. WA is 500 and MB is the molar mass of what? Molar mass of ethanol, which is also given, that is 46 into 1000. So when you will calculate, you will get the answer 3. So the depression in freezing point is 3. So out of the 4 graphs given, you have to select the one which is showing the depression of 3. Okay, so you can see that this can be observed in the first graph because 270 and 273. So the difference is of 3. Similarly, it can be seen in the graph third also. That means A and C, both of these graphs are showing the depression of 3 degree. Okay, that means the correct option has to be from the A or from C. Now, out of A and C, your correct answer should be C. Why C? Because in the A graph, you can see that when you are decreasing the temperature, you can see when you are decreasing the temperature, the vapor pressure is increasing, which cannot be possible. Okay, when you decrease the temperature, that means less vapors are produced. So less vapors are produced, so vapor pressure cannot increase. Vapor pressure increases only when the temperature will increase. Okay, so this graph is actually not drawn correctly. So the correct graph is this. Okay, so A and C, out of these two graphs, the C is the correct option. Okay, because it is showing the change of 3 degree. Okay, the delta TF is 3, as well as with a decrease in temperature, the vapor pressure is also decreasing. This question says the freezing point of benzene decreases by 0.45 degrees Celsius when 0.2 gram of acetic acid is dissolved in 20 grams of benzene. The moment you see the question, your first and foremost duty is to write the values which are given to you. Okay, so here you are given delta TF, that is 0.45. Okay, and acetic acid is a solute, so its mass is 0.2 gram. Okay, molar mass of acetic acid, that is not given, but when you will calculate CH3COH, you will get 60. Okay, now WA, that is the mass of solvent, so which is 20 grams. They have asked you to calculate the percentage association. Percentage association, that means you have to first calculate alpha, the degree of association, and to convert it into percentage, you will multiply it with 100. Okay, so how you will proceed? You will use the formula delta TF is equal to IKF into WB upon MB WA into 1000. Okay, now delta TF given is 0.45, KF value given is 5.12, now WB 0.2, MB 60, 20 and then 100. Okay, so when you will solve, you will get the value of I as 0.527. Okay, so this is the value of I. Now you will use the formula of alpha. For the association, the formula of alpha is I minus 1 upon n minus 1. Okay. Now what is n? N is the number of molecules which are undergoing the association. Okay. In this case, you can read in the question that it is given that it is forming dimer. Dimer means 2 molecules are undergoing association. So value of n here, it is 2. Okay. So when you substitute all the values, you will be getting I value, you will substitute 0.527 minus 1, 1 upon 2 minus 1. Okay. So when you will solve, you will be getting 0.944. Okay. So 0.944 is the value of alpha, and to convert it into percentage, you will multiply it with 100, and so you will be getting 94.4. Okay, so its answer is nearly 94.4. So option D is a correct option. Now this is the fifth and the last question of this video. This question says 5 gram of sodium sulfate. So sodium sulfate is a solute. Its mass is 5 grams. It is dissolved in X grams of water. That means WA is X. The change in freezing point, delta TF, that is 3.82. Sodium sulfate is 81.5% ionized. That means the alpha is 81.5%, or you can say it is 0.815. Okay, the value of X. Okay, so how you will do this question? You will first calculate the value of I. You know, the formula of alpha is I minus 1 upon n minus 1. I will substitute all the values which are given to me. Alpha given is 0.815 is equal to I minus 1 upon n. N is what? See, sodium sulfate, when it will be ionized, it will give you 2 of sodium ions and 1 of sulfate ions. That means total number of ions are 3. Okay, so value of n here is 3. 3 minus 1. So when you will solve, you will get the value of I 2.63. Okay. After getting the value of I, you will apply the formula delta TF is equal to I KF into M. M is the molality. Now you put the values again. Delta TF, it is 3.82 is equal to I value is 2.63. KF value, it is also given. KF is 1.86 into M is molality. Molality is WB upon MB. WB upon MB. WB is 5 divided by MB. MB is the molar mass of sodium sulfate. So that you can calculate. You will get 142. Okay. So this is WB upon MB, and then WA. In the denominator, you will multiply with the WA. WA is the mass of solvent, and the mass of solvent, this you have to calculate. So you'll put it X, okay, in 2000. So when you solve, you will get the value of X as 45.09. Okay, so that means the correct option of this question is option C. Okay, option C is the correct option. So I hope that you have understood all the 5 questions which I have taken up in today's video. I will keep taking more of these kind of questions in a set of 5. So if you want to subscribe and you like my video, then you can share with others and you can subscribe to my channel. Thank you.